Okay, the topic that I'm going to discuss is equilibrium of rigid bodies in three dimensions. This is a continuation of my previous video about equilibrium of rigid bodies. The first one was about equilibrium in two dimensions. The second was about the special case on two and two force and three force body. So this time I'm going to discuss about three dimensions, equilibrium in three dimensions. We saw in the early part of this chapter that six scalar equations are required to express the conditions for the equilibrium of a rigid body in the general three-dimensional case. Okay, summation of force x equal to 0, summation of force along y equal to 0, and z equal to 0. And then summation of moment about x equal to 0, about y, and about z equal to 0. So we have six scalar equations. So these equations can be solved for no more than six unknowns, which generally will represent reactions at supports or connections. So maximum of six unknowns. In most problems, the scalar equations will be more conveniently obtained if we first express in vector form the conditions for the equilibrium of the rigid body considered. So, conveniently obtained now, these equations will be conveniently obtained if we first express in vector form. So, we are going to express force and moment in vector form. So we write summation of force equal to 0 and this one. Summation of moment which is R cross F equal to 0. So ang force will be expressed in vector form. So after writing this equation, express the force F and position vectors R in terms of scalar components and unit vectors xi, yj, zk. Next, we compute all vector products for this one for moment, either by direct calculation or by means of determinants. And then after that, by equating to 0, the coefficients of the unit vectors in each of the two relations, this one, first one, second relation, we obtain the desired scalar equation. So all coefficients of the unit vectors, i-group nimo and then equate to 0. Meaning, for forces, group all components having the unit vector I and then equate to 0. That's equation 1. And then group all terms or components containing the unit vector J and then equate to 0, equation 2. And then all terms with unit vector K, i-group sad and then equate to 0. That's equation number 3. And also with moment. After conducting vector product, you will also have terms with unit vectors I, J, K, i-group sad nimo, and then equate to 0. So another 3 equations. So all in all, you have 6 equations. Okay. For the supports, these are the reactions at supports and connections. Okay, so for a ball, notice that for a ball, it is free to move in this one plane, no? XZ plane. If this is X, Y, and Z, for XZ plane, free siya move. Therefore, there is no reaction about sa X-axis. No reaction also sa Y-axis. Sa Z-axis, sorry. Z-axis. You only have one reaction along Y-axis, this one. Same with frictionless surface. Okay. Only have one reaction. For a cable, one reaction also. One unknown, one unknown. With known line of action, this one. For a roller on rough surface, for this one, for this orientation, the roller is free to move in this direction X. Therefore, there is no reaction along X-axis, this one. But it is not free to move along the Z and the Y-axis. So therefore, there is a reaction sa Y and Z axis. Same with wheel on rail, free to move along X, but not free along Z and Y. And then rough surface and ball and socket, not free to move along X, Y, and Z. Therefore, na reaction sa X, Y, and Z. Free to rotate, so there is no moment. And then this is for universal joint. Okay. Free to rotate along Y and Z. Free siya rotate sa Z, but not free siya. Free to rotate sa X. Dili siya free sa X, so therefore 9 moments sa X. For a fixed support, restraint tanan. No movement, no rotation. So, 3 unknown reactions, 3 unknown reaction forces, and 3 unknown moment na reaction. MX, MY, and then MZ. Okay. For a hinge and bearing supporting radial load only, free siya mo move along this axis X. So, free siya mo rotate. So there is no reaction about or along this axis and moment also. Okay. For pin and bracket, free siya mo rotate sa Z nga x-axis. Free siya rotate about the x-axis. So there is no moment sa x-axis. Same also with this. Free siya mo rotate. So no moment reaction sa x-axis. Okay. So let us solve some problems. A 5 by 8 feet sign of uniform density weighs 400 pounds and is supported by a ball and socket joint at A and by 2 cables. Determine the tension in each cable and the reaction at C. Okay. So, cut na to, and then we have tension in EC. And then also for this one, cut, and then tension BD. And then we have reaction, ball and socket. Ano? So, again, pag ball and socket, this one, we have 3 unknown forces sa reaction. Ball and socket. So, 3 unknown reactions sa A. So, we have EX, EY, and then EZ. Let's assume positive na direction AX. Naman din positive na X. So, Y, nada positive. Sa Z, sa nada. And then last force is ang weight niya. 405. So, let us express all forces in vector form. Now, for EC and BD, we need the distance formula. I mean, sa vector form, need na to ang distance from B to D and from E to C. So, distance BD is this one. As discussed sa force in space, to get the distances, components is inani. You start from B, you move to D. So, from B, you move this way. That's negative 8i. Okay? Another positive. So, it's negative 8i, this one, negative 8i. And then you go up. That's 4, positive 4j. and then move this way, that's negative 8K. Ang positive nga K kaya dire man. So it's negative 8K, this one. And the magnitude or the distance from B to D is 12 feet. For EC, from E to C, so you move this way, negative 6I, and move up, that's positive 3J, and then move this way, that's positive 2K. Positive siya. Okay, this is for EC, negative 6I plus 3J plus 2K. Okay. So this is for one. This is the force in vector form. Scalar value, TBD, over distance, components na yun. Negative 8, positive 4, negative 8. And then you distribute this one, TBD over 12 times 8, you will have this. And then you do the same for TEC. Negative 6, positive 3, positive 2. And then for RA, you just write AXI plus AYJ plus AZK. And for weight, since the weight is parallel sa y-axis, you just write the magnitude and then you attach the unit vector. Like this one. Okay. So to have three equations, ani na summation of force equal to 0. Group all terms containing the unit vector I. So, or use some force along X, so all components with I. This one, I, this one, and then EX. And then equate to 0. Do the same for Y and Z. So Y, 1/3 TBD, 3/7 TEC, AY, minus 405. And then for K, emission of force Z, this one, negative 2/3, positive 2/7 plus EZ. Now, from this, we have 5 unknowns, TBD, TEC, AX, AY, AZ. So we cannot solve any of those unknowns. So let's denote them as equations 1, 2, and 3. Okay. The second relation is a emission of moment equal to 0. So sa support, sa ball and socket. And since moment is a cross product of R and F, we need a position vector. The position vector of BD, remember that position vector starts from the point where you want to get the moment up to the tail of the force. So the position vector of TBD will start from A and will end at B. And that is simply positive 8I. For TEC, it's simply 6I. And for weight, supposed to be, ang weight na to is this one, 4I minus 2.5J. No? Kaya 8 man siya. So, 1/2 is 4. And then nasa center, 5 ni, so 2.5. So, the position vector of the weight should have been 4I minus 2.5J. But if you will use the principle of transmissibility, weight can be placed here. Dire, no? So therefore, ang unit vector nimo or a position vector rather will only be 4I. 4I lang, right? That's our position vector for W. Okay, after this, perform cross product and then equate to 0. So 8I cross sa FBD or TBD. This one. This is TBD. Okay, plus EC, 6I cross TEC. Of course, no movement for AX, AY, and AZ. Okay? They will pass through point A. Wait na lang. So it's 4I. Okay. Now, okay. That is why useless ang negative 2.5J na part sa unit vector. Because if you will add negative 2.5J, useless man. Kaya pag mag-cross product ka, J, cross J, 0 lang man yapon. Di ba? So, useless. Pwede rin na dili include ang negative 2.5J and thus you will use principle of transmissibility wherein you can transfer the weight there is a upper portion along its line of axis. So, equal to 0, perform cross product. I cross I, 0, I cross J, I cross K, and everything. Make this as your guide. No? IJ, K, IJ. Moving to the right, positive. Moving to the left, negative. So, if it's I cross J, the answer is K. The movement is to the right, so positive na. Okay. We have this one. 8 times 1/3 is 8 over 3 TBD, positive K. Kaya ngayang plus star is I cross J man, I cross J. The answer is K. This one. Do the same sa other terms and you will get this. Like for example, this one, last term, I cross J. I cross J is positive K man. Pero kay negative and positive man, negative. 4 times 405 is 1620. So, equilibrium conditions, there is no moment about X kaya we don't have any term containing the unit vector I. So for this one, all terms with unit vector J, combine mo. And then last, summation of moments at Z equal to 0. All terms with unit vector K combines. And the result is we have two equations with two unknowns. So you can use method of elimination, method of substitution if you want. And you can solve for TBD and also TEC. Now, after solving for TBD and TEC, you can go back to equations 1, 2, and 3 to solve for AX, AY, and AZ. So, from 1 to 3, you now have the values of TBD and TEC. Therefore, you can now solve for AX, AY, and AZ. This one. AX, AY, and AZ. So, una na lang ang 3 dimensions. Just make sure na distances nimo correct and also in performing cross product correct also. Another problem. The rigid L-shaped member EBC is supported by a ball and socket joint at a ball and socket again. So 3 reactions, Ball and socket joint at A and by 3 cables, CD, BD, and BE. If a 450-pound load is applied at F, determine the tension in each cable. Now, for E, we have 3 reactions, AX, AY, and AZ. And then for tension, i-cut na to. You have tension CD, and then cut also this one. Nata tension BD, and then cut ne. You have tension BE. Okay, so next is get the distances. Distance of CD, distance BD, distance BE. For CD, there is no X component. And so it's negative 32K positive 24J. So we have this one, 24J. We follow the XYZ na what? Plus star, no? 24J and negative 32K. The distance is 40. For BD, you start from B, going to D, so move this way. That's negative 42, no? Negative 42. And then this one, negative 32, but K. K means negative 32K. And then you go up, positive 24J. This one. For BE, we don't have Y, we only have X and Z. So Z, negative 32, X is positive 42. No Y component. We have this 42 and negative 32. Okay, so after this, pwede na ka sa vector form sa force. Okay, so TCD, scalar over magnitude 40 and then components. 24J, negative 32K. And then you distribute. Okay. Money ang CD. Also for BD, the distance is 58. Negative 42. Just copy this one. Negative 42I. 24J minus 32K. And then BE. BE is this one. TBE over magnitude 52.8. And 42I minus 32K. And then reaction sa A and the 450 na load. Okay. So after this, same lang. Group all terms containing I, J, and K, and then equate to 0. You have 3 equations. This is very easy. You just have to group similar terms. And so we have 6 unknowns: TBD, TBE, TCD, AX, AY, AZ. We have 6 unknowns. So since these are equations 1, 2, and 3, we still need 3 more equations. Momenta, R cross F man. So what's the position vector of CD? Remember, a position vector na to will start sa support up to the tail of the force. So for CD, it's simply negative 42I plus 32J. Take note sa direction. This is positive X. So going this way, positive X. Going up, positive Y. Going this way, positive Z. So for CD, we have negative 42I and then minus, plus 32K. So for BD, BD is simply this one, 32K, no? Same also with BE. Dili maghapon ang tail, so it's 32K. And then the last one is this one, position vector of this. So it's this one, 32K minus 21I. Okay, 31I niya, 32K. So after this, you're gonna perform vector product. Okay. Starting with CD. This is RCD and F dayon CD. And then BD. R of BD, 32K, and then you have BD. This can be found sa previous na slide. Okay. And then BE, 32. Muna components sa BE. And then last is ang sa kini 450. So, position vector of F, this one, negative 21I plus 32K. Cross name mo sa F niya, which is negative 450J. Now, you perform cross product. I cross J, I cross K, K cross J, K cross K. And collect all terms. One yung guide, don't forget to use this guide. Okay. One yung result. Nanay I, J, and K. So, 3 more equations to use. Okay. This is the equation of moment, or R cross F. So, first, summation of force about x-axis. So, group all terms with unit vector I. This one, TBD, and then this one. So, you have 2 unknowns. Y. This one, 1, 2, 3. Okay? And then Z. This one, duha lang, no? It's negative 25.2 PCD plus 9,450. So, from here, from here, you can solve for TCD. Pwede sad ka mag 3 equations with 3 unknowns. Using your calculator, unknown number 1, unknown 2, unknown 3, TBD, and you can solve for TCD, BD, and BF. Pwede, ano? You may not use method of elimination, by just looking at this one, you can solve for TCD. After solving for TCD, substitute mo dire, you can solve for TBD. Yeah. And with the values of TCD and TBD, you can solve for TBE. Any method you want. No? And from equations 1, 2, and 3, we already have solved the 3 tensions, BD, BE, CD. We can now solve for the components. So we have this one. EX, EY, and EZ. That's the result. Okay? After pag-substitute sa tulo ka tension, mao niya ang result sa components. And then this problem, the assembly shown is welded to collar A that fits on the vertical pin shown. The pin can exert couples about the X and Y axis, meaning mo resist siya about X and Y. Mo exert siya couple about X and Y. But does not prevent, meaning free to move about or along the y-axis. Pag about gani moment, along is force. Does not prevent motion about the x-axis. Therefore, there is no resisting moment about x. Kay free man siya mo move about the x-axis. Free siya mo move along, y-axis. There is no rotation about the y-axis. Free siya mo rotate. Free siya mo move along the y-axis. So, there is also no reaction along y-axis. So, for this one, for letter A, we only have 4 unknowns. Reaction sa X, moment sa X, reaction sa Z, moment sa Z. For Y, it's 0. Okay? So, 4 unknowns, 2 tensions, 69. So you cut tension CE, cut also tension DE. And then EX, EZ, moment sa X, and moment sa Z. So we have 6 ka-unknowns. So first, distance again. Distance of CF, it's negative ETI plus 60J. 0 ang Z-axis, 100. Next, TDE. Okay, 0 sa dang X, positive 120J and minus 90K. So for the forces, this is TCF, 100 ang distance, and then TDE, kana, no? And then reaction sa A, AXI, wala man ang Y, di ba? So AX and EZ only. And then kining force nimo 480 downward, so negative G. Next is formulate equation. Sum up of force along X, combine all terms with unit vector I. Do the same for Y and Z. So for Y and for Z, we have this one. We have 4 unknowns: TCF, TDE, AX, and AY. So we need more equations. Okay? We have equations 1, 2, 3. Sa moment, no? So, kuha na to ang position vector sa CF and DE. For CF, it's ETI plus 135. Kaya ano, from E to D man na. So, it's positive ETI, positive 135. 135 man eh. 135K. And then for DE, positive ETI, positive 90K. And then last dere, force. Ang 480 o ang CF, pareho lang. Kaya ang distances niya kay going this way, positive 80, positive 135. Pareho lang. So for moment, you perform cross product. This is for CF, ETI plus 135K. This is CF, di ba? Sa previous na slide. Plus DE. This is also tension DE. And then sa F times this distance. And then we also have MX and we also have MZ. So MXI plus MZK. Perform cross product, of course, with guide. Perform cross product and then combine like term. So this is the result. You can check this one if you want. And then sum up kag moment about X, combine terms with unit vector I. And also for Y and Z. So from here, we still have many unknowns: TCF, TDE, MX, and NZ. We have 4 unknowns. Di hapon pwede ma-solve, no? So let's denote this one as equations 4, 5, and 6. Next, is i-combine na to ang equations from 1 to 6. This is equation 1, 2, and then 3. And then equation 4, 5, and 6. So we have 6 equations with 6 unknowns. Pero, dili sa yung naka-difficult. Sa'yo lang nino. So the only equations without the reaction components are 2 and 5. So, i-combine ang 2 and 5, we can solve for TCF and TDE. equation 2, equation 5. Okay? So, i-combine na you can use your calculator if you want, but you can use elimination or substitution. TCF is 200 while TDE is 450. Okay? Now, after this, you can go back to any of the equations aside sa 2 and 5 and you can solve for the ano. Example, using equation 1, na naman kay value sa TCF, this one, 200. And you can solve for AX. Muna itong AX. Next, equation 3. Na kay TDE, 450. This is A. Easy. Next, 4. You can solve for MX. And then equation 6, you can solve for NZ. Okay. So you already have solved the 6 unknowns. So I hope that you have learned something from this video. Okay. So 3D requires more practice, no? Less analysis, but more practice to fully understand the topic. Okay. So once again, thank you for watching.